Okay, so let's do some practice problems. So is this a multiple of 3a? So can I factor a 3a out of this? I sure can. So I get 2 times a plus b, correct? So this 6a, I should write that first, I guess 6a, a plus b, can be written as 3a times this, so it is a multiple of 3a. Okay, is this quantity here divisible by 4? So I'm just going to go slow here. I'm going to say this is 2 times 3m, and I'm going to factor out a 2 and m plus 5, right? Now I'm going to pull these two, put them together, so then I'll have 3m times m plus 5. So is this quantity here divisible by 4? Yes, because I can see the factor of 4. So yes, divisible by 4. Okay, so going over exactly knowing what this divides thing means, just taking baby steps here. Does 7 divide 34, right? So does 34 equal to 7 times some k value? No. So does 4 divide 0? Is 0 equal to 4 times some k value? Yes. K equals 0, right? Okay. Does 0 divide 4? Does 4 equal to 0 times some k value? No, it does not. Okay, so let's move on to this one's a little bit different. If n is equal to 4k plus 1, and we'll be kind of seeing more things like this. If n is equal to 4k plus 1, does 8 divide n squared minus 1? So n squared minus 1, substituting this in, gives me 4k plus 1 squared minus 1. So this gives me 16k squared plus 8k plus 1 minus 1, right? So this simplifies to this. And can I say that 8 divides this? I can, because I can factor out an 8. So yes, 8 divides n squared minus 1. Okay. What about this? If a, b, and c are all integers, if a divides b and a divides c, show that a divides b plus c. Okay, so let's go slow. So we have to take what each of these means. A divides b means b is equal to ak, okay, where k is an element of the integers. A divides c means that c is equal to a times t. Again, remember, you have to use a different letter where t is an element of the integers. Okay, so let's go find out what b plus c is equal to, substituting in. So b is equal to ak, c is equal to at, and if I factor an a out, so what I'm looking to show is that a divides, and I have it right there, right? So this shows that a divides b plus c, because I've got it written as an a times a k plus a t. All right, let's do something a little different. So if I have ab divides c, oops, sorry. Okay, if ab divides c, then a divides c and b divides c. Okay, so ab divides c. That means that c is equal to ab times k, where k is an element of the integer. So I always start off with the definitions. Okay, so what am I looking to show? I'm trying to show a divides c. So all I have to do is rewrite this, maybe even say let p equal bk, right? So I have c is equal to a times p. So this shows that a divides c, because I've written c is equal to a times p, where p is an element of the integers, right? Then I can take this same statement and rewrite this as b times ak, and then let q equal ak. And so I can write c is equal to bq, and that means that b divides c, where q, I guess I should say q is an element of the integers. So just kind of playing with the definitions.